All right, welcome back to Chapter 1.2 video lecture. Looking at sampling techniques, and statistical inference. All right, so we talked about in the last video, the ideal is to get a truly random sample, which means that everyone in the population has an equal chance of being selected in the sample. But often this isn't feasible. A list of the entire population may not be available, or it may be impossible or too difficult to contact all members of the population. Every 10 years, the federal government of the United States tries to do a survey questionnaire of the entire population. That's called a census, not a sample. Census is trying to get to the entire population. And I would argue, and the federal government would even admit, that it's impossible. You can't get to every single 300 plus million person in the United States. So it would be impossible, at least now, to get a truly simple random sample of all United States adults. So sometimes your population has to be altered to something more feasible to sample from. Let's just say you want to ask someone about how much video games they play in a given week, but the only way you could do so is through social media, Twitter or Reddit or Facebook or something like that. You can still do your study and do your sample. You would just have to generalize only to people who play video games and who use social media. Okay, so look at some bad methods of sampling. Sampling is based on something related to the variable you are studying. Okay, so this is kind of a very subtle issue that can come up. Let's give me a couple examples to explain what I mean. Suppose you want to sample students in the library when asking how much they study. What could be the problem with this by only asking students in the library? Well, hopefully you thought something about if students are in the library that they might be the students that study more. So you might get students study 25 hours a week on average, when that's just not true. Maybe students at the library study that much. Or if you sample only students taking a statistics class. We're going to use our class as a sample a lot throughout the semester, but I'm going to consistently argue that our class is not a good representative sample of all students. Not everyone has to take statistics. Not every student is trying to transfer to a four-year school. So as a class, since you're taking statistics, you are already a different part of the population than the whole thing, the whole population. Another example, suppose fitnessmagazine.com asked, have you ever hired a personal trainer? And 27% of the respondents said yes. If this is all we know, can we infer that 27% of all humans have hired a personal trainer? Hopefully you're skeptical about this. Hopefully your answer is no, but why? Why do you think you would say 20%, 27%? Multiple ways to answer this, but I think that if a person is already going on to fitnessmagazine.com, they're visiting this website, they're probably already more likely to hire a personal trainer than someone who doesn't go to the fitness website. So this number is probably too big if we're looking at all humans. There's nothing wrong with this data. You could still take this number and say, 27% of people that visit a fitness website have hired a personal trainer, but not all humans. All right, volunteer bias is a huge issue. You're going to be collecting your own data a couple times this semester, and almost all of your samples will have some type of volunteer bias. Sometimes it's called a convenience bias, letting your sample be comprised of whoever chooses to participate. All right, my two favorite examples to talk about this are Yelp. If you go on Yelp, that's completely a volunteer sample. You have to choose to go on Yelp and review the restaurant or business after you do it. And it tends to be a lot of times, not always, but a lot of times with volunteer bias, you get ratings or reviews that are either really high or really low. So someone who really loves their experience or hated it will review, or you get groups of the population that just like giving reviews that are not representative of the entire population. My second favorite example of this type of thing is Rate Your Professor, Rate My Professor. Whichever one it is, the one rateyourprofessor.com. You can definitely get good information about me and all your professors on there. But you got to keep in mind, generally, who is making those ratings? Usually it's the students that really love their professor or really hated or had a bad experience. Might not be truly representative of that professor. So people who choose to participate or respond are probably not representative of the entire population, as I was just mentioning. So if you email or mail, or even as I mentioned, doing like a Reddit, or Google poll, or do some type of information gathering on social network, it's probably not good to make conclusions about the entire population. Think about who chooses to respond. Probably not the entire population. Another example, if an airline emails all of its customers asking them to rate their satisfaction with their recent travel, I would guess most of those emails just get deleted. That small percentage that respond, the airline can still get some good information, but I would still say it'd be biased information. All right, so kind of looking at that picture again, we've got this big amorphous population. It's changing, and we have a sample. So the first issue that can come up is we could have some sampling bias. Again, we're going to, after the first couple weeks of this class, we're going to move on and just assume all of our samples are good. That's a big question in research. Making sure you have a good sample that is representative. Then you have data. Going from sample and analyzing data, there could be other forms of bias. Again, we're just going to focus on a couple. There's whole classes and areas of study dedicated to sampling biases and other forms of bias that could exist in statistics. So even with a random sample, data can still be biased, especially collected on humans. And other forms of bias to watch out for in data collection could be wording. Question wording, context, inaccurate responses, and just in general. There's no limited list of biases here. I just want to focus on a couple of these. Say question wording. And two different surveys were done. These were a little bit older, in 2012. Do you think the United States should allow public speeches against democracy? And in another survey, do you think the U.S. should not forbid public speeches against democracy? So the second question here is got the double negative, not and against, but these are essentially asking the same thing. Should the U.S. allow public speeches against democracy, freedom of speech, but just asked in a slightly different way? In the first question, 21% said speeches should be allowed. In the second one, 39% said speeches should not be forbidden. So if you think about here, this is really saying 61% said speeches should be allowed. So you got a 61% versus 21%. That's a 41% difference in the response. And the only thing different between these two questions is the wording. Oh, excuse me, I forgot. This was experiment on wording. This was done much more than 10 years ago. So wording can be very important. And we'll do an exercise in class, an activity on how you could try to change wording to thereby change the responses. All right, a random sample was asked, should there be a tax cut or should money be used to fund new government programs? When this was asked, the response was tax cut 60%, programs 40%. A different random sample, so it's a different group of people, but a random sample was asked, should there be a tax cut or should money be spent on programs for education, environment, healthcare, crime fighting, and military defense? So really same questions, except just adding more detail to these government programs. Get rid of the phrase government programs and put all this information. And suddenly they go from tax cut 22% and program 78%. So a 28% swing, more than a quarter swing, just changing the word, which is a huge deal if you think about it. And that comes from this experiment done in psychology journal. Inaccurate responses is another question I used to ask in class when I had just a regular non-hybrid class. In a study on U.S. students, 93% of the sample said they were in the top half of the sample regarding driving skill. So you can think about this number can't be more than 50%. There's also an issue of self-rating, rating oneself at any particular skill. And a random sample of all U.S. college students, 22.7% reported using illicit drugs. Do you think this number is accurate? This is from 2010, so it's a little bit older survey. The survey was done about 10 years ago. 22.7%. Or I should say, do you think that number is higher or lower? Most experts think the number is higher. This was a self-response. When there's any type of negative thing, whether it's drug consumption, alcohol, junk food, how much you work out, humans tend to, I don't want to say lie, but exaggerate or round up or round down to make themselves look better. And really the best thing you can do is always think critically about how the data was collected. Recognize that not all forms of data collection can lead to valid inferences. In the next section, we're going to look at headlines and how sometimes a quick summary, chocolate cures cancer, video games lead to more pay, could sometimes be misleading as well. So always, if you see a headline somewhere, it's good to dig deeper, especially if it's important and you think it might affect your life. And this would be the easiest way to instantly become a more statistically literate individual. So my hope is, by taking this class, and we're going to look at some articles. I actually have a couple podcasts you're going to listen to kind of help you get more skeptical, but healthily skeptical when you look at statistical analysis and statistical statements.